Flim Dog Science with me, Caleb Flynn. Subscribe, like, comment, and hit that bell. Science lovers, welcome to Flim Dog Science. Today we're going to be thinking about lungs. These guys right there. To help me, I got Tall Tom here. Tom has helped me understand the general placement of anatomy organs probably better than anything else. They're a couple $100, so it's not super inexpensive, but it's been really useful. How much air is actually inside your lungs? That's what I'm really curious about. So we're gonna do a little at-home spirometry lab. Here's how you do it. The supplies for the spirometry lab that you need. 2 straws. What you do with your straws, if you take the bendy end and the bendy end, and then put the middle pieces together. Push them together, and then if you get a little piece of tape, the tape will help keep air from escaping. So we got our straw. You need a little basin of water. I like to use these apple juice containers. They're 2.84 liters. So if you want to do this really exactly, I'll show you how you can do that. If you want to do general, just to see how much is in your lungs, you can know that every one of these has 2.84 liters, but whatever plastic container you use, just look at the volume that's there in liters. Step 1 that we're going to need to do is fill up our bottle with water, whatever bottle you have. Once you have this full, cover the top and then flip it over in your water basin. This is full of water. Okay, right there, just like that. I'm gonna try to get one actually that you can see a little better in. Now, depending on how big you are, you're probably gonna need more than just one jug. The average adult male has about 6 liters of air that will fit in their lungs. You can't get to all of it, and we'll look at some of the terms associated, but you can get to a good chunk. So I'm probably gonna need another jug here that I can fill up with water. So let me get one more prepped. I have my 2 bottles full of water now. What I would recommend doing is filling up your basin full of water and then fill the bottles up with the water from whatever your water basin is. Otherwise it will get a little bit wet. You'll probably get some overflow, which might be fun. Maybe fill up the water and then fill up the bottles with extra water and watch what happens. So what we want to do now is we have to flip these over and put our straws in. Bottles are flipped. Now I made an extra straw. I'm gonna put one underneath each one. If you wanted to do a really cool one, you could maybe make like a split straw. Let me know if you come up with some cool idea. I'm just gonna do 1 straw on each one, and it's gonna go just underneath the bottom. It just got a little wet. All right, so straw goes underneath. What I'll do is I'll blow into one, and when if I'm able to completely empty this bottle, I'll just start blowing into this one next. Let's see how much air I got in my lungs. This one, we're gonna try to find what's called the vital capacity. I'm gonna take my deepest breath and then blow out all the air that I possibly can. And then we'll try to find some other things after we found that. So first, vital capacity. That's about all I could do right there. Let me try it one more time. One thing I forgot, I started blowing into this one, but the weight of the bottle was blocking. You have to kind of lift up on the bottle or else the air can't get in. So let me try it one more time and I'll see if I can get a little better result. And this one looked like it was about 3 liters. We got just a little over our 2.8 here. One thing I noticed is even though I put a little tape on here, I still hear some air that is moving out of the straw. So I'm gonna try this time using a little bit of fish tubing. All right, I got 2 pieces of fish tubing here. So I'm gonna try those instead of the straws and see if I don't lose as much air. Now you have to be careful with fish tubing or if the straw goes too high inside the water, because if you blow some bubbles, you may end up finding the water keeps emptying once you're done. Now I'll put a link to a couple of videos that I made on that. It's kind of a fun phenomenon you can think about, but we'll just know we have to be aware of that. Trial number 2, as much air as I can breathe out here, the vital capacity. Big breath. Try that one more time. I don't think I'm gonna be able to hold this one at the same time. Whew, that was a good one. So I did 1.5. Without being perfectly exact, I did 2.84 and then half of one of the 2.84s. That would be my vital capacity here. If you wanted to be really exact, what you can do, let me show you. Flip the water back over. Get something you can measure with. I happen to have these beakers. They give me a little more accurate measurements. They go by 200 milliliters. So if I put that here, there's 1,400 milliliters of water. That means everything else of the 2.84 was air. So that would be my vital capacity when I add those together. Trying as hard as I could, I just filled up about 4,280 milliliters worth of air. That means there was about 2 liters of air that was left because the average adult male has about 6 liters of air that's in their lungs. So where was that extra 2 liters hiding? If we think about your lungs like a plastic bag that's wet, your body doesn't want the walls of your lungs to touch. Otherwise, they'll stick together, kind of like this plastic bag. If the walls touch, they stick together. Your body doesn't like that because it's really hard to overcome this when the lungs have touched. So what your body does is it keeps a little bit of air inside your lungs that you can't get out, and that keeps the lungs from touching. This is called the reserve volume. Now there's another value we can find called the ERV, the expiratory reserve volume. Normally you're breathing in and out with what's called the tidal volume. You go, just normal breaths. The tidal volume is a small amount of air in terms of percentage of what your lungs are. It's like half a liter or so of that 6 liters that's there. So in order to calculate your expiratory reserve volume, what you're doing is you're saying at the end of your normal breath, when you breathe out, there's still more air you could breathe out. And how much is there? Well, what you would do is you would breathe out and then breathe all the additional air that you could and measure it. So we breathe out and measure that volume. Let's try. Woo. So we see my expiratory reserve volume is just slightly less than that 2.84 that fits inside the bottle. There is maybe a couple hundred milliliters left, probably like 2.6 liters or so was my expiratory reserve volume. There's another volume you can find called the tidal volume. It's your normal breath in and out. And the way that you would find that is you would just breathe out like that. The challenge is as soon as you try to breathe into a straw or into the fish tubing, you actually have to try to blow that air in, and that's gonna make your rib muscles, called the external and internal costal muscles, and your abdominals flex. And so the stopping cue for your normal breath ending sort of goes away. What I'm gonna do is try to just blow some air into this balloon and then put the air from the balloon inside my fish tubing. For this to work a little better, you'll want to blow the balloon up so it's nice and loose. Otherwise, you'll have to try hard to fill it up too. Balloon's a little looser. Let me try to do my tidal volume now. So my tidal volume, let me see if I can put that in the straw here without losing too much air. Okay, so that would about be my tidal volume. And if I wanted to measure that exactly, we could get our big beaker out again. Let's try that. And we'll put our water inside our beaker and then subtract 2.84. So there's 1,800 milliliters here. If we take our 2.84 and then subtract this 1,800 milliliters as liters, that's 1.8, we get 1 liter. 1.04. My guess is if it's supposed to be about half a liter, maybe I forced out a little extra air there, but that would be finding your tidal volume using the balloon. The last thing you can find is called your inspiratory reserve volume. It's when you breathe in, and then there's more air you could breathe in. So you breathe in. All that extra air is the inspiratory reserve volume. If you're really confident in your tidal volume and your expiratory reserve volume, then you can just subtract those two from your vital capacity, and then that would get you your inspiratory reserve volume. We're just going to breathe in. We're gonna suck in the air in the bottle. So I'm gonna make sure I get the straw all the way to the top here, like this. I'm gonna take a normal breath in, and then I'm gonna breathe in everything else that I possibly can, and we'll see the water fill up here. Okay, there it is. My inspiratory reserve volume. I took my breath in, normal tidal volume, and then I breathed in everything else I could on top of that. And the amount that I actually breathed in is the amount of water that got pulled in. So this time I'm going to measure the water that got pulled into the spirometer. I lost just a little water when I was flipping it over, so it's probably fairly close to 1,400. So about 1,400 would be my inspiratory reserve volume. My inspiratory capacity, which is my tidal volume plus my inspiratory volume, that's called the inspiratory capacity, was about 2.4. So that's a few things you can find using a fun little spirometry lab. If you like that, consider subscribing, and we'll come back and do some more anatomy, physics, chemistry experiments here real soon. Have a great day.